by lenses. Alvina, I'm audible, dear. Hello.
Yes, sir, you're audible.
Hello. Assalamu alaikum, Alvina. How are you, dear?
Walaikum salam. Fine, thank you.
Okay, that's good. I'm also fine, dear. Okay, so that is the first question that is in front of your screen, everyone. So please solve it and let me know the answer.
Okay, sir.
Let me know the answer in the chat. Okay, Arya.
So it will be N, and then like in the subscript GW, right?
What are you saying, Arya? Please repeat.
Like it will be N, and in the subscript it will be GW, right?
It in subscript it will be G. In the superscript that will be W because we are
W.
taking with yes, with respect to water.
Okay.
Any answer from anybody? Yes, everyone. Any
The
answer?
answer is 1.125.
Okay, Alvina, please let me know in the chat so that I can compare who gave the right answer. Okay, I got the answer from Alvina and Albina and Arya. Aisha, you are left, Bijit. Please answer. Okay, so look at the screen, everyone. So the question is saying that refractive. Achha, I got one more answer. Check, Aisha, koi baat nahi, no worries. So question is saying that refractive index of a glass with respect to air is 3/2, and the refractive index of water with respect to air is 4/3. So the 3/2 and 4/3, which kind of refractive index it is? It is relative or absolute?
Relative.
Okay, Arya said relative. Albina, Nuha, and Aisha, what it is? Is it relative or absolute?
Relative.
Relative. Okay, ठीक है. Is this Albina?
Sir,
Check.
relative.
Relative. Check. Okay. Aisha say Aisha. I think Aisha gave the answer. Noha, have you given the answer?
Yes, sir, I
Sir,
said
glass,
relative.
Check. Yes, somebody
sir,
is saying something.
glass with respect to water is relative.
Okay, who is this? I think it's Noha.
Alvina, Alvina,
Acha, Alvina. Check, Alvina. So glass with respect to air, is it absolute or relative, Alvina?
it's relative.
Glass with respect to air is relative or absolute last
Respect to
time?
air is respect to air is absolute.
Absolutely. Yes, absolutely right, Alvina. So only Alvina is right. So basically, I've told you when the two mediums are involved and one of them is air, so that relative index will be absolute relative index. Okay. Okay. As you can see that 3/2. So it is basically with respect to air. So this refractive index of glass with respect to air, it is given to you as 3/2. So this is an absolute refractive index, and relative refractive index of water with respect to air, it is 4/3. So we need the refractive index of glass with respect to water. So it means that if I write down in terms of refractive index of glass with respect to water. So in the last class, I have told you that when we deal with the speed in the refractive index, we take the reference in the numerator, right? This is the thing that I've told you. Yes or no, everyone?
Yes,
Yes.
Please
sir.
say yes or no. Okay. But when we deal with the refractive index in terms of absolute refractive index, the reference part will be in the numerator. Sorry, denominator. If I'm saying that refractive index of glass, so refractive index of absolute, the absolute refractive index of glass will be in the numerator. Absolute refractive index of water will be in the denominator. So refractive index of glass with respect to water in terms of absolute refractive indices. Is this clear to all of you? Please let me know once.
Yes, sir.
Okay. So it is 3/2 divided by 4/3. As you can see, this is a double division. Okay. So this just a second. And that is 4/3. This is equals to 3/2 into, sorry, 3/4. So this is coming out to be 9/8. So it is coming out to be 1.125. So it is T. Clear, everyone? Please let me know once.
Yes, sir.
Any doubts so far to anybody? Please say yes or no.
No, sir.
No,
Okay.
sir.
Okay, everyone. So this is the refractive index with respect to of glass with respect to water. Clear? That's how we calculate this. Okay. So this is the question related to refractive index. Okay. Now it's time to move forward to the image formation by the spherical lenses. It's a very important topic. Okay. So image formation by spherical lens. Clear? So this is the image formation of spherical lens. So basically in this in the syllabus of yours, we have two types of lenses. First one is convex lens. Second one is concave lens. Basically, the properties that you must have in the reflection part, you have done that concave is the converging mirror. Yes or no? In the reflection part,
Yes, sir.
but in the lens part, concave is diverging. It spread out the light. Okay. In the reflection part, convex was a diverging mirror, but in the lenses, convex is a converging lens. Okay. So in this, the properties basically got swapped between these two, right? Okay, so just a moment, let me draw the convex lens shape. So this is the convex lens shape, and this is the concave lens. This is how the concave lens looks like. Okay. The center of this of the lens is called optical center. Just like we have done in the mirrors, that was pole, but in the lenses, it is called optical center. Clear, everyone? Please let me know once. Is this
Yes,
clear to
sir.
all of you? Please say yes or no. Okay. Yeah. But one more thing is, so let me write it here. Just a second. So my pen is a little bit. So the center point lens is called optical center. Okay, in the lenses, we measure all the distance from the optical center. Clear, everyone?
Yes, sir.
What is that? Mariam. Hello, Mariam. Assalamu alaikum, dear. Why are you so late?
Yes, sir.
Hello, assalamu alaikum, Mariam. How are you?
Walaikum assalam wa rahmatullahi wa barakatuh. Sir, I'm fine, sir. Alhamdulillah. How are you?
I'm fine, dear. Alhamdulillah. Why are you so late, dear? Why are you so late?
Sir, I got a message from the team saying there is no class today.
Acha. So maybe there was some mistake here.
Yes, sir.
Yeah, chalo, theek hai, clear. So I've just started the class. No need to just one question has been done in the refractive index. Okay, so this is the main topic that we've started right now. So image formation by spherical lenses. So we have two types of lens, convex and concave, and the center point of the lens is called optical center. Clear, everyone? Okay. So let me tell you the principal focus. What do you mean by principal focus? So principal focus is the point on its principal axis to which the light ray converges. When the light ray are basically parallel to the principal axis, the convex lens will direct those rays on the point. That point is called principal focus. Clear? So the principal focus convex lens is a point principal axis to which light ray is parallel to the principal axis converge after passing through the lens. Clear, everyone? So this is the principal focus. So basically, we have two focuses on the lenses because light can travel in both the direction. Because in the reflection, light comes back into the same medium, but in the refraction, light goes from one medium to another medium. Yes or no, everyone? Okay. So let's understand this thing in the convex lens first. Then we will do the concave lens. Okay. Okay. So what about the convex lenses, dear? That okay. So this is optical center O. This is focal focus 1. This is 2f1. So this is nothing but your center of curvature. But in mirror, we say this has center of curvature, but in lenses we say is 2f1. Okay, twice of the focal length. Clear, everyone? Okay. And on the left hand side, one more focus is there, that is called f2, and this is 2f2. So everyone, as you can see this thing, that light goes in this direction. Yes or no? Light, we assume this thing light travels in this direction. Yes or no? Bolo, yes or no?
Yes, sir.
Okay. And the optical center is the point from which we basically observe the distances, right? So you can see this thing that O is here and I'm going in this direction. So is this positive or negative? The focal length will be positive or negative for convex lens? Please tell me.
Positive.
Positive by Arya. What about rest of you? Jaldi batao.
They're positive.
Positive.
Positive, sir.
Positive. Is obviously positive because we are going in the direction of light, so it will be positive. So this, the focus which is in the direction of light will be called as principal focus. So if I'm writing only F, it means that I'm taking this one, right? Okay. Yes or no, everyone? Is this clear?
Yes, sir.
Okay. Yeah. So the focal length of the convex lens is positive. Okay. And next is called convex lens, is called converging lens as well because it basically directs the light to the focus, right? convex lens is called converging lens. Clear, everyone?
Yes, sir.
Okay. As one more thing is that the object distance will be negative, because object we always place in front of the you can say the mirror or the lens. Yes or no? Okay. So object distance will be same for all the lens or mirrors, right? Okay, that's great. Okay, so let's do the image formation by the lens. Yes or no, by the convex lens. Okay, so this is the image formation. So the first case in this is the at infinity, when the object is at infinity, very similar to the you can say the reflection part. Okay, 3 and 3 6. So it is the middle. Okay, so this is the optical center, and this is the f1. This is 2f1. This is f2. This is 2f2. Okay, so as you can see that first that object is at infinity, so rays will be parallel to the principal axis. Everyone, yes or no? The ray will be parallel to the principal axis when the object is at infinity, and it will pass through the focus. Clear, everyone? Like this. Is this clear to all of you? Please let me know once. Any doubt to anybody?
No, sir.
Sure? Clear here?
Yes, sir.
Sure, that's great. So as we can see, so U, just a moment. So U is at infinity. Infinity. Image is forming at focus, that is f1. Nature will be real and inverted. So convex lens always form real and inverted in except one cases. One case. Only one case is there in which it does not form real image. Clear? Similar to the concave mirror. Okay. Size will be highly diminished, or point size. As you can see that there is no height of the image, yes or no, so it will be highly diminished. Please let me know, everyone, is this clear to you or not?
Yes, sir.
Any doubt to anybody, please let me know once. Please tell me.
No, sir.
Chalo, theek hai. Now the object will move towards the optical center. The next position will be, can you tell me what should be the next position? Can anybody tell me what should be the next position?
At F1.
No, at not f1 here. It will be beyond 2f2 now. It will move towards beyond 2f2, next will be 2f2, then between 2f2 and f2, then at f2, and then it will be to f2 and o2, right? That's how we will proceed. Okay, Arya?
Okay, sir.
Okay. So the object is placed beyond 2f2. Okay, so let me write it here as well. Second ray, first ray should always be parallel to the principal axis and it will pass through the focus. Second ray, I will take that will directly pass through the optical center. So when the light ray passes from the optical center here, that it will go without any refraction, without any bending of light, okay? Because it strikes the light at 90 degrees, so that's why there is no refraction. I've told you in the first class of the refraction that when the light ray falls normally on the surface, it will go without any refraction. How many of you remember this thing? Yes or no? Yes or no? At least say yes or no. Do you
Yes,
remember?
sir.
When the light ray falls normally to the another medium, it will go without any refraction, right? So this is the intersection point of the refracted ray. So as you can see this thing, that refracted ray. So this will be your image. Clear? This will be your image. So it will be U. Just a moment. Is beyond to F2. V is between F1 and 2F1. Okay? And next would be nature. Nature is real and inverted. And size will be, what will be the size? Can anybody tell me? Bolo? Nobody knows? Size will be diminished now because it is less than object, so it will be diminished. Clear, everyone? Please let me know once.
Yes, sir.
5 students are there in the class, but nobody is responding. It seems like nobody is taking this class attentively. What happened to everybody? Please say yes or no. What happened? Nobody is
Yes, sir.
basically responding at all. Even asking yes or no, no one is responding. That's not a good thing, Vicho. If I'm asking continuously, so you should have answered me at the first point. So say 5 students are there, nobody is responding. It seems like that only one-way interaction is happening. So that will not benefit you. Okay. So you should be interacting with me continuously so that you can understand the terms. Please let me know if this is clear to all of you or not, these two terms, these two topic cases of the convex lens.
Yes, sir.
Yes, sir.
Check it. This is very important topic, everyone. If you don't understand this thing properly, so you won't be able to implement the lens formula because lens formula is associated with this. Okay. So that's why I'm requesting to please understand and let me know if you have any doubt. Okay. So next, now the object was beyond 2F2. Now the next now the object will be at 2F2, right? So here it is 3 at 2F2. First ray should be parallel to the principal axis and it will pass through the which point? Still no one
Can
answered.
you repeat?
F1.
I'm asking if the line is parallel to the first ray is parallel to the principal axis. Where should it go?
F1.
F1. Yes, F1. So it will pass through the focus, primary focus. Okay. Next ray I will take that will pass through the optical center. Okay. So as you can see this thing, that image is forming exactly at 2f1, sorry. This is the point, that is 2f1. Okay. So your image, your object is forming at 2f, object was placed at 2f2, image is forming at 2f1. Nature, real, inverted, size will be same. Okay, same size. Okay, everyone.
Yes, sir.
So let me take this. So this is the third case. This is the fourth case. Now the object will move towards the optical sensor. So center. So it would be between 2f2 and f2. Okay, so object is basically placed between 2f2 and f2. Okay. First ray should be parallel to the principal axis and it will pass through the focus. Second ray, it will go to it will pass through the optical center. Okay. So there will be a little bit asymmetry. So please pardon me for that because I'm drawing rough-handedly. So this is the case. So as you can see this thing, the image is forming beyond 2f1. Clear, everyone? Okay. Image is forming beyond 2f1. Any doubts so far to anybody? Please let me know once.
No, sir.
No,
Okay.
sir.
No, sir.
So, yeah. So U is basically beyond or between 2f2 and f2. And V is basically beyond to f1. So nature will be real, inverted. Size will be, can anybody tell me the size of this image?
Diminished.
Diminished. Okay, who gave the answer?
Sir, Aisha.
Okay, Aisha. Rest of you, Alvina, Mariam,
Diminished, sir.
diminished. Okay.
Diminished.
Will it be bigger than the
Okay, Mariam is saying something. Yes, Mariam, go ahead with the answer. What are you saying?
sir, it will be larger.
It will be larger. Okay. Obviously, you can see this thing, but so that image is absolutely greater than the object. So it would be enlarged, no? Okay. So this is the fourth case. Is this clear to all of you? Please let me know once.
Yes, sir.
Okay, next case would be next case would be when the object is at 2f, sorry, f2. The object is at f2. So the first ray should be parallel to the principal axis. Okay. And the second ray, oh sorry, the refracted ray will pass through the focus. Yes or no, everyone? Okay.
Yes, sir.
Yes, sir.
S- just a second. And the second ray will pass through the optical center. Okay. And it will pass through the optical center. So all of you can see this thing that light rays are parallel to each other. The refracted light rays are parallel to each other. So where they will meet, can anybody tell me the name of that place? Where does the parallel light ray meets? At infinity. Infinity is the point at which the parallel in light rays meets. Okay. U. Now your U is at f2. V is at infinity. And nature would be real and inverted. Size will be highly enlarged. Here, everyone.
So shouldn't it be highly diminished?
Why highly diminished, Arya? Tell me the reason.
Because like I
The
don't get how it's
object,
highly enlarged.
when the object is placed at focus, the rays become parallel to each other. So obviously the image will be formed very bigger. Okay? When you use a telescope, this is the point at which we basically use the telescope at focus point. That's why we can easily see the celestial objects, because that is a kind of, you can say, a bigger image is formed of those very small objects. When the object is at infinity, then the image formed will be highly diminished, because the rays will converge at focus. So there is no height of the image. You can see directly. Okay?
Yes, sir. Got it.
And right now, your image is basically forming at infinity. So obviously, there is no, you can say, you can see this thing that image will be highly enlarged. Clear?
Yes, sir.
Any doubt to any of you?
No, sir.
Okay, now the last case is that object will move between F2 and O. Okay, so between and O. Okay, so let me paste this thing. Now the object is between F2 and O. So the first ray will be parallel to the principal axis and it will pass through the focus. Clear? All in each case, first ray should be parallel to the principal axis and will pass through the focus. Second ray will pass through the optical center. So all of you can see this thing that these two rays are getting diverged. Okay, they are getting farther away from each other. Got it?
Yes, sir.
Okay.
Yes, sir.
Okay. So will there be any real intersection between these two rays? Hello?
No,
No.
sir.
Will no, na. So what we will do is that we will assume that these two, if we extend these lines in the backward direction, they are gonna meet. Okay. So that's why I'm extending the lines. Now you can see this thing, they are meeting at this point. So this point will be your formation of image. So all if you can see this thing, that is a virtual image because okay. So virtual image. So you can see this thing, the object is placed at F2 and O, is placed between F2 and O. So U is basically between F2 and O, and V is basically on the same side of the object. V is forming where? On the same side of the object. Okay. And nature would be inverted. So not really inverted, it would be virtual and erect. Sorry. And size would be your size would be enlarged. Clear, everyone? Please let me know once if this is clear to you or not.
Yes,
Yes,
sir.
sir.
Any doubt so far to
Sir,
anybody?
how is the size enlarged?
Dear, you can see this thing. This is your object. This is the image formed here. Yes or no? So
Yes,
image
sir.
is, you can see this thing, height of the image. That is, height of the image is smaller or larger?
It's larger. Sir, where is the
It's
image formed?
this is the image formed here. This is okay, everyone. So just a moment. So these lines that I've extended in the backward direction will be drawn with dotted line like this. You can say dash line. Okay. So because I don't have the dash line in this case, so that's why I've drawn with the normal lines, but you have to use the dash line.
Okay, sir.
Okay. Whenever you draw the, you can say the extended line, you have to draw with the dashed line. Please let me know, everyone, is this is clear to you or not?
Yes, sir.
Any doubt so far to anybody?
No, sir.
Sure, is this clear, all of you? I've tried my best to draw the symmetrical images, symmetrical ray diagrams. As you can see this thing that I've drawn my, like I've tried my best, but there would be some minor asymmetry. So please pardon me for that. Okay. But when you will draw with the scales, it will be completely symmetrical, right? Yes or no, everyone?
Yes, sir. Yes, sir.
Yes, sir.
Sure. That's great. That's great. Just allow me a second. Okay. So these are the 6 cases of the convex lens. Clear? So that's how we draw the images using the convex lens. Okay. Next thing is that, just a second, let me paste the summary of the ray diagrams. Everyone, have you got the book of Lakshmi Singh and Manjeet Kaur from the management? I have shared with them. Have you got the book? The reference
No,
book, Lakshmi
sir.
Singh, Manjeet Kaur? You haven't read the
No,
book?
sir.
Just a second. So, okay, no worries. I will ask them to share them right now. Share this book right now. Okay. So, okay, so this is the summary of this table. Like this is the opposite of this because I have taken the sequence from infinity to between focal, optical center and focus, but they have taken this in the opposite manner. So no need to worry. They have taken the virtual case first, and then after that, all the real cases. Okay, but we have taken the first real cases and then virtual case, right? So there is no need. Just you have to remember this thing. Clear? Everyone, is this clear to you or not? Please let me know once.
Yes, sir.
So,
Chalo, that's great. Okay. Now we can understand. Now let's understand the uses of convex lens. Where do we use the convex lens in real life? Because sometimes this is a 2-marker question that comes into the exams. So first of all, convex lens is used. So convex lens is used in the spectacles to you can say correct the eye defect called hypermetropia. So hypermetropia is the eye defect in which we cannot see the near objects clearly. Okay, so this lens is used to correct that defect. Okay. Hypermetropia. Is this clear to all of you, bacho? Please let me know once.
yes, sir.
Yes, sir.
Bacho, the book has been shared with you, but you are saying that book is not shared with you.
So, when did they share?
Sir, did they send it in the account or through WhatsApp?
Through WhatsApp, dear, because this is the book. This is not the assignment, dear. So this will be shared on the WhatsApp itself.
Sir, but I didn't get.
Okay, ठीक है, I'm asking to share it again.
Thank you, sir.
Okay, so they are sharing right now. So, okay, so please check out in your WhatsApps. Okay, so that is a book. That is a very good book. You can say that it's good for practice. It is good for explaining. You can say the explanation given in this book is very good. You can say it have multiple real life examples. It have MCQs. It have subjective questions. I'm not saying you have to do all the questions, but yeah, you can take some of the questions, at least MCQs and some short questions, so that you can practice them for the exams. Okay. this book, I'm referring this book because I've also taken the reference of this book when I was in 10th standard. Okay, so I've downloaded somewhere from the internet as the PDF format, because this PDF format is not that much available of this book, but somehow I got this book. But okay, so right now I'm sharing it with you. Okay, so and along with NCRT, you can take the reference for this book when after this class, when you want to read out something from the book, you can take this book as well as your reference. Okay.
Yes, sir.
Yes, sir. Thank you, sir.
Welcome, dear. Welcome. Okay. Okay. Next thing, that is the use of convex lens, is that convex lens is used in simple cameras. Okay. So these are the two, you can say, or one more thing is that convex lens is used as a magnifying glass. The last case. Okay. Is this clear to all of you? Please let me know once. Any doubts
Yes,
so
sir.
far to anybody?
No,
Yes,
sir.
sir.
Are you sure?
Yes, sir.
Yes,
Chalo,
sir.
theek hai. So this is all about the convex lens, everyone. Okay. Now it's time to move forward for the concave lens. Okay. Next thing that we have is concave lens. So concave lens. So concave lens is called diverging lens. Okay. Just a moment. Let me take the picture of this. Okay. Hmm. So all of you can see this thing. Okay. So just a moment. So this is the 3. And this is this principal axis. Okay. So all of you can see this thing, that when the light ray, so basically suppose that your object is basically standing here. Okay. Okay, I'm not basically marking the F1 and F2 and all. Okay. So the first ray will be parallel to the principal axis. So convex lens basically converges towards the principal focus, but this lens basically diverges. It basically spread out the rays, okay, after refraction. Am I clear to all of you? Please let me know once.
Yes, sir.
Is this clear?
Yes, sir.
Yes, sir.
Okay, sure, that's great. Okay, let's talk about the about the concave lens. That is, first part of the concave lens is that concave lens is a diverging lens. Okay. Second thing is that the focal length of concave lens is negative. As you can see this thing, suppose this is the ray. All of you can see this thing, that without this is the refractive first, second refractive ray. This is the first. So is there any intersection between these 2 points? No, no. But when I extend this line in the backward direction, so there is a meeting of this point. Okay. So you can see this thing, that I'm drawing the line in the backward direction. It means that the images formed by the concave lens will be virtual and erect. Yes or no, everyone? Because they are not actually meeting. I'm just assuming that they are going to meet in the backward direction. Bolo, yes or no? Yes or no?
Yes, sir.
Yes,
Any
sir.
doubt so far? Is this clear? This point is clear to you or not? What
Yes, sir.
happened?
Yes.
Dekho,
Yes,
be
sir.
honest with me. If you are honest with me, then then I will be able to understand that whether you are getting my point or not. If just you are saying for the sake of my convenience that yes, I got the point, that is a thing that will not benefit you. So you have to be honest with me. If this is not clear, so please you say, at least say no, sir, I didn't get this point. Please explain it again. Yes, I get this point. So be confident while answering, because it seems sometimes it's look like that you are not confident in your answers, that you sometimes let you 50-50 that yes, I got it or not. I don't want that thing. I want 100% confident. If you get my point, and if you don't get my point, say boldly yes or no, I don't get the point. So there no need to be like you can say that shy. Okay, so please let me know once if this is clear to you or not, that image formed by the concave lens will be virtual and erect. Is this clear? Why is it happening?
Yes, sir, clear.
Sure,
Yes.
that's
Yes,
great.
sir.
ठीक.
Yes, sir.
That is the confidence I need in your answers. ठीक है. So the concave lens virtual and erect images. Clear? Third would be, as you can see, this is the optical center, everyone. That, and this is your F1 and this is your F2. So light ray are not going to meet in this direction, but they're meeting at this point. This is called F1, sorry, F2. And this is your F2. All of you can see this thing that we have always measured the distance from the optical center. So it means that here is the focal, because light is basically intersected at this point. So I'm going in the backward direction, in the opposite direction of light. So it will be negative, yes or no, everyone?
Yeah.
Got it? Okay. So the
Yes.
focal length for the concave lens will be negative. Okay. अच्छा देखो, एक चीज याद रखना हमेशा, that whenever you hear the word concave, whether it is lens or mirror, so focal length will be negative for this. Focal length for concave lens and concave mirror is negative. Whenever you hear the word convex, your focal length would be positive. Okay, always remember this thing. Did you get my point, everyone?
Yes, sir.
Yes, sir.
Sure?
Yes.
Sure, that's great. Okay, so this is all about the basics of the you can say concave lens. Okay, now it's time to just a second. I got Arya, could you please give me 20 minutes for this class, dear? Because that I've told you that this would be 1.5-hour class. Okay, I will do one thing. I will do one thing.
Okay, sir.
15 minutes. 15
Sir,
minutes. Ha, yes, Alvina.
no, it's Nuha, sir.
It's yes, no, ha.
Sir, I'm going out, so can I leave this meeting?
Okay, so you're asking to leave the class. ठीक है, चलो, you can leave. चलो, कोई बात नहीं. So you can watch the recording because this class is getting recorded. So you can watch the recording.
Okay, sir.
So can I also leave?
Okay, ठीक है आर्या. ठीक है.
I'm so sorry,
अलवीना,
sir.
कोई बात नहीं, चलो,
I'm
कोई
also
बात नहीं.
going out.
Thank you, sir.
ठीक ठीक, कोई बात नहीं, no worries.
Thank you, sir.
Mariam and Alvina,
Bye.
welcome. Yeah, bye. Mariam and Alvina, you are here, Namache. So
Yes,
let's complete this topic. Only 15 minutes, not more than that.
Okay.
Okay. Because this image formation for the concave lens will be done, and the uses of concave lens. Two cases are like only two cases are there in the concave lens. This is a small one. So image formation. Actually, they both have to go for the dinner, so that's why they left the class. Image formation by. Sorry for my bad writing. Actually, it's right now slipping. Like my hand is very slippery right now due to the humidity.
It's all
No,
right,
sir.
sir.
Thank you. Okay. So the image formation by concave lens. First case is similar to the all the cases at infinity. Your object is placed at infinity. Okay. So let me copy this thing. Okay, just a minute. Yeah, here it is. So your object is at infinity. So rays for incident ray will be parallel to the principal axis and it will pass through. It will basically diverges. Yes or no? Because it is a diverging lens.
Yes.
Yes.
I'm trying to draw the like a figure as much as possible, like symmetrical as possible. So you have to practice this thing, okay? Because if you don't practice, you will just forget it. So it's very important to practice this, okay?
Yes, sir.
Okay, as you can see this thing, they are not gonna meet. Absolutely not. Yes or no? Okay. So what will happen is that we will extend this line in the backward direction like this. So this line, okay? Okay, as you can see, this will be dash line. Okay, always remember, mark them in your copies that this will be dash line because I don't have dash line in the option. So that's why I'm drawing with the normal line. So this will be a dash line. As you can see this thing, bacho, that when extending in the backward direction, the image formed is virtual and it's highly diminished. Yes or no? Because it is making, it is basically forming at focus. Yes or no, Mariam and Alvina?
Yes, sir.
Yes, sir.
Okay, okay, that's great. So U is at infinity and V is forming at F1. Okay, nature would be virtual and direct.
Sir, it's formed at F2, right?
Okay, okay, sorry, it's F2. Sorry, dear, sorry. So it's
Okay.
F2, virtual and okay, and size would be highly diminished. For concave lens, this is the primary focus, okay? Because all the images are formed on the left hand side. Clear? In the concave
Yes.
lens, in the convex lens, primary focus is F1. Clear, everyone?
Yes, sir.
Chalo, that's good. Next one is between infinity and O. You can place the object between infinity and O anywhere. Okay. So the image formed will be same. Just a second. This is the case. So as you can see this thing, first ray is parallel to the principal axis. It will diverges, yes or no. When I extend this line in the backward direction, it is meeting at F2, right? And the second ray
Yes,
will
sir.
pass through the optical center without any refraction. So you can see this thing, this is the intersection point of these two refracted ray, bacho. Alvina and Mariam, is this clear?
Yes, sir.
Sir, where is the O placed?
This is the O, dear. This is the O, optical center. This point, middlemost point, center.
Okay, sir.
Okay. So this point is the
Okay,
O
sir.
point. Okay. Yeah. So as you can see this thing, the image formed is diminished and virtual and erect. Clear, Mariam and Alvina? So U is basically anywhere is basically between infinity and O. Okay, V is basically between F2 and O. Okay. And nature would be virtual and direct. Okay. And size would be diminished. Is this clear to both of you, Bacho? Please tell me.
Yes, sir.
Any doubts so
Yeah.
far to you?
No, sir.
Are you
No.
sure? So
Yes,
these
sir.
are the two cases of the concave lenses. You can see this thing, the name got swapped in the mirror. From in the mirror cases, we used to do 6 cases for concave mirror, right? But in the lenses, we used to do 6 cases for convex lens. But in the mirror, we used to do 2 cases for convex mirror, but in the lenses, it is for concave lens. Got it?
Yes, sir.
The basically it got swapped.
Yes, sir.
Sure, that's great. Now let us understand the, just a moment. Just a second. Give me a second, Bachu. Just a moment. I'll be now. So let's do the use cases of the concave lenses. Okay. So the first case is that concave lens is used to correct the eye defect called myopia. So when the persons who are not able to see the distant object, it means that far objects, that they use concave lens to correct their eye vision. Okay.
Yes, sir.
Do you wear any spectacles, Alvina and Mariam?
Yes,
Yes,
sir.
sir, I do.
Which concave or convex?
Sir, concave.
Concave.
Concave. So both you both have the myopia.
Yes, sir.
Yeah.
Okay. Concave lens. I'm also a myopic patient. But I don't use spectacles because like it seems a little bit you can say a very tough task for me.
Sir,
So
lenses.
lenses. To wearing lenses looks like that I have some burden on my face. So that's why I've never like I've wore it for some time, but then I've spectacles. Then I left. Using spectacle to correct. Called myopia. Okay. Second thing that we have is, just a moment. So concave lens is used in the telescope, like complex telescopes. Okay. So complex telescopes uses so concave lens is used as islands. Islands means from which we basically see the objects in the telescope or microscope. Lens in Galilean telescope. There,
Yes, sir.
the third case is, just a moment. So you must have seen that spy hole in the doors that we used to see the unknown strangers from the door itself without opening the door. Yes or no?
Yes, sir.
In that spy hole, concave lens is used. Okay.
Yes, sir.
Is this clear to all of you? Please let me know once. Any doubt so
Yes,
far
sir.
to Mariam and Alvina?
Yes, sir.
Do you have any doubt?
No doubt,
sir.
sir.
No doubt. Sure, just a second. Okay. So this is the summary of the concave lens. Only two cases are present. So as you can see that two cases are present. So we'll be using these so this is the, you can say, summary that all the two cases are there and the six cases are there in the convex lens, right? Okay. So
Yes, sir.
this is a very important topic, everyone. If you understand this clearly, you will be able to apply the lens formula in a very clear manner. Okay. So that's why please revise this thing, practice as much as possible, and reflection part as well. In image formation by spherical mirrors is also a very important topic. You have to practice because then you will be able to understand and implement the mirror formula. So these two topics looks very similar, and if you understand any of them, either refraction or reflection, you can easily make the you can easily make any ray diagram if you understand this properly. Please let me know if this is clear. Can you can you draw the diagrams right now, ray diagrams? Bolo?
Yes, sir.
Okay. So I will be giving you some questions after this class, everyone. So I think four or five questions will be there. And thought that will not be the ray diagram form questions, but some basics questions. Okay. And in the next class onwards, we will do the you can say the numericals based on this topic, and we'll start the lens formula. So only one topic is left. That two topics are left. That is lens formula and power of lens. So lens formula and power of lens can be you can say done in. So next two classes will be the last two classes of this chapter. Okay. I hope this is clear to you. So after this chapter, we will start electricity. So are you fine, both of you, with this chapter, electricity, or do you want to start any other chapter?
No, sir. Electricity.
इलेक्ट्रिसिटी ठीक है मरियम. अलवीना आप बताओ.
Yes, sir.
इलेक्ट्रिसिटी ना, बिकॉज देखो ये दोनों चैप्टर्स जो है ना थोड़ा लेंदी है. सो इट्स बेटर कि हम लेंदी चैप्टर्स और न्यूमेरिकल फोकस चैप्टर को पहले कंप्लीट कर लेते हैं, बिकॉज वो हो सकता है आपके मिड टर्म्स में आने के सबसे ज्यादा चांसेस होते हैं. जो बाकी दो चैप्टर हैं, दैट इज ह्यूमन आई एंड मैग्नेटिज्म, वो थियोरेटिकल चैप्टर हैं कंप्लीटली. उनमें कोई भी न्यूमेरिकल नहीं है, सिर्फ एक न्यूमेरिकल है उसमें, क्या बोलते हैं आपके ह्यूमन आई में, वो पावर ऑफ लेंस पे बेस्ड है. अगर आपने पावर ऑफ लेंस इस चैप्टर में कर लोगे, वो इजीली आप उस वो कर सकते हो, वही है एज इट इज कॉपी पेस्टेड टॉपिक. ठीक है. सो हम हम नेक्स्ट क्लास नेक्स्ट आफ्टर दिस टॉपिक, आफ्टर दिस चैप्टर विल स्टार्ट इलेक्ट्रिसिटी. सो इलेक्ट्रिसिटी बहुत अच्छा चैप्टर है, थोड़ा सा लेंथी है, टाइम कंज्यूमिंग है. सो एटलीस्ट आई थिंक 8 या 9 क्लासेस लगेंगे उस चैप्टर को कंप्लीट करने में, क्योंकि काफी लेंथी चैप्टर है, मल्टीपल टॉपिक्स हैं. ठीक है. सो अभी आपके उसमें क्या चल रहा है मरियम स्कूल में?
So we're having exam on June 3.
जून 3, ठीक है। मिड टर्म्स?
Electricity, no, 20 mark.
अच्छा, पीरियोडिक।
Periodic test. Yes, sir.
ठीक है,
And
ठीक है।
physics electricity chapter is coming.
फिजिक्स इलेक्ट्रिसिटी चैप्टर इज कमिंग।
Sir, I requested the team for extra class, so they said they'll arrange one on this Saturday.
ठीक है मरियम, ओके, नो इशू। सो okay, so I will take your class, okay, no need to worry about this thing, ठीक है।
Sir, but
So
will we be able to complete before the exam?
uh, uh, do you have basics in your mind?
Yes, sir, a few.
A few, chalo, ठीक है। So what we'll do is that we will try to focus on numericals and the main theory, ठीक है।
Yes, sir.
So that will basically helps you to understand the chapter, not thoroughly, but at least you can easily done the chapters, right?
Yes, sir.
ठीक है। So I will take your class, no need to worry about this thing, ठीक है। So like at least 20 marks क्वेश्चन, और 20 मार्क्स में से 20 मार्क्स सिर्फ फिजिक्स का पोर्शन है या फिर 20 मार्क्स होल है?
20 marks whole, 7 marks
होल
for physics.
फॉर फिजिक्स, चलो ठीक है। सो ज्यादा चांसेस यही है कि आपके मेन न्यूमेरिकल्स पोर्शन ही आए। अलवीना, आपके स्कूल में क्या चल रहा है?
We have finished chemical reactions and reflection chapter and
So this
refraction
light
as
is complete. Light is
yeah.
completed.
Yes.
Check. Light is completed. So it means that next chapter would be electricity or something else.
I don't know. She started acids, bases, and salts.
अच्छा, सो बेसिकली दे आर डूइंग केमिस्ट्री। ओके, ठीक है, कोई बात नहीं। सो आई होप कि जब तक आपका एसिड बेस एंड ये सब कंप्लीट होगा, सो हम लोगों का भी लाइट चैप्टर कंप्लीट हो जाएगा। सो देन अकॉर्डिंग टू हम लोग लाइक ज्यादा चांसेस तो इलेक्ट्रिसिटी के हैं, क्योंकि इलेक्ट्रिसिटी इज द चैप्टर दैट इज बेसिकली अ वेरी हाई वेटेड चैप्टर इन द 10th स्टैंडर्ड। सो दीज टू चैप्टर्स, हाई वेटेड चैप्टर्स विल बी डन आपके क्लासेस में। सो आप कॉन्फिडेंट फील करोगे, ठीक है। सो बाकी थ्योरेटिकल चैप्टर हैं वो तो ज़्यादा नहीं, 3-3 4-4 क्लासेस के हैं ज़्यादा से ज़्यादा। बट ये चैप्टर्स ऑलमोस्ट 9 to 10 क्लासेस के थे, तो ऑलमोस्ट इसकी भी 6 से 7 क्लासेस हो गई हैं हमारी भी। बेसिकली इसकी क्या बोलते हैं आपके इसके लाइट चैप्टर की 1 2 3 4 5 6 7, हाँ 7 क्लासेस हो गई, 7 to 8 क्लासेस, ठीक है। सो ओके, सो दैट्स ऑल फॉर दिस क्लास।